Okay, let's start. So that's a presentation that covers all the contents. Just to introduce what we have done, we already seen a lot of that in the previous user groups back last year and this spring. We will focus more on the differences, and that will be an introduction to the work that John has done for UK Post Office. Usually I present this with Emanuela, but she has already covered that in the previous part, so we will go faster on that. So the shift to container is quite inevitable now, based on what all the analysts are saying. That moved to different stages. So starting with hybrid clouds, with partially adopting public clouds, then the containers, and now it's going more with the cloud native and microservices. That's part of different shifts, different trends that are moving together. So on one side, development processes are moving from waterfall to agile to DevOps. The architecture has gone from monolithics to multi-tier and now to microservices. Deployment was initially on physical servers, now are on VMs, and are now going on containers. And at the same, we started from data centers, hosted environments, and now on pure cloud. About the importance of containers, those are data from Gartner. Back at the end of last year, 30% of organization was already using containers in production, but the estimation is that in 2022, that will be 75% of the organizations using containers in productions. And especially when we are talking about microservices, the forecast from Gartner is that in 2022, 90% of the new application will be built on microservices, and 95% of microservice application will be deployed in containers. So that's quite inevitable. That's changing all our companies. And so we have to understand how to manage that. Just a short introduction about containers. So when we move from traditional deployments on physical machines to virtual machine, we introduce hypervisors and guest operating systems. With containers, we have the same isolation benefits of VMs, so in terms of storage, networks, even resources allocated to processes. But at the same time, we don't have different kernels running, a different operating system to patch, and the applications are coming in containers images already, including all the prerequisites. When we are talking about containers in development, small deployments, we're talking about Docker Compose. When we're talking about Kubernetes, containers in production, Kubernetes is key, because that allows to manage a large cluster with multiple nodes, where the application can be distributed across the cluster. It takes care about high availability. If we lose a node, containers running on that node are automatically restarted on other nodes. And that also provides all the network layers and storage orchestration that allows to move application easily from one machine to another without having to do anything. First part that you already seen in the previous user group, so I will be very quick here, is we have applications in every companies that are moving to containers and to microservice architecture. Why and how we can use work automation to manage these containers, these applications. Work automation is still very important because it allows to automate complex flows. So if you see Kubernetes, we just have cron jobs there, but that's not enough, and that is not easy to manage. We still need a product that can orchestrate hybrid workflows spanning from on-premise, mainframe, and now public clouds, containers, Kubernetes, and that can do on all the flexibility that we provide in work automation. And key factors are the possibility to monitor all the workflow from a single point, and to also have regulations, so security, auditing, all done in a single place. So that simplifies all the regulation compliance activities. models to schedule containers are the simplest one that we can have in mind, but is not suggested, is to include agents and application in the same container. The bad of that is we still have a lot of dependencies about having the same OS distribution, the same libraries. We have to build containers in each company, so every customer has to build their own containers and maintain their own containers, and so we're not really leveraging containers. So we have to find new ways of running workload in containers. The first pattern is the one that applies to microservices. So in all these situations, you have containers running permanently running 724 and exposing their capabilities to APIs. It can be REST APIs, JDBC connections, whatever. And in this case, we can have an agent in a different containers and remotely schedule this job through the RESTful job, database jobs, or the job types that works remotely already. So that's quite easy with what you already provide. And so you just have to take our agent container image, deploy that in Kubernetes, and schedule those jobs. The new pattern that replaced the first one is how we can schedule applications that run temporary, so executable script Java mains that just need to start, do some work, and then complete. Instead of including them in the same containers, the best pattern is to use what Kubernetes calls jobs that are basically temporary containers that are started, do some work, and then complete. We have a new job type that we've seen this spring, that is the Kubernetes job, that allows you to do this. So submit and track Kubernetes jobs, collect the logs, clean up the environment, and that. And the benefit of this is the coupling agent and applications that at this point can have their own containers, and also allows Kubernetes to distribute the workload across the cluster. And this was the screenshot on how to define this job. The new chapter that also John will present today is how, now that we have a Kubernetes cluster, how we can leverage that to deploy our workload automation environment. So how we can take benefits of that. We started supporting that in our journey, especially with 9.5. So in 9.4, we just have a do your own agent container in order to start scheduling application container. But with 9.5, we started with IBM Cloud Private Certification, then with FlexPack 1, providing the agent for OpenShift, with FlexPack 2, full support of all our servers on OpenShift, adding also Operator, that has been certified both as Red Hat certified container, but also as IBM certified container for CloudPack in June. In September, we added the support with the AKS for AKS. We are supporting AKS with M charts. They are published on GitHub as open source, and that allows basically to take these M charts and reuse them for any Kubernetes environment. Containers are supported on any container runtime, so you can take the M charts, modify them, and adapt to the specific Kubernetes deployment that you need. We fully tested them on EKS, where we also provide suggestions on how to use, for example, the AWS load balancers. We are currently working for customers moving from on-premise to Kubernetes. Right now, it's possible to do that, stopping the master, transferring the definitions, and restarting on Kubernetes. With FlexPack 3, we provide also a parallel upgrade procedure so that you don't have to stop the production while moving from on-premise to Kubernetes. And for next year, we have additional supports for different public clouds. So we will start supporting AKS directly. So say it's already somehow supported and possible, but we will fully test that, certify that, provides a specific recommendation for Azure. The same for Google. And we're also looking to provide support for disaster recovery using multi-cluster. So basically masters on one Kubernetes cluster and backup on another Kubernetes cluster. So to have more remote support for disaster recovery procedures. Right now, it's possible, for example, with Kubernetes to use multi-zone deployment. So if you have closed data centers, you can make disaster recovery just leveraging Kubernetes. And there are also some new packages for Kubernetes that allow to use multiple clusters as a single cluster. So that can be another option. We're also looking to support more Z, containers on Z on mainframe. And that both for Z-Linux, and so also in the future support OpenShift for Z-Linux, and also use the Z-Linux containers on z/OS with the ZCX capability. So, for example, to run the DWC on containers directly on z/OS, or also Z-centric agents. As we were saying, the goal is to have the same container image that can run on all the environments. So from a container perspective, it's always the same container. That simplifies our work, but also your work. You can easily adapt the container to any different Kubernetes container runtime and platform. That's the architecture that of what we provide with the AWS distributed on Kubernetes. Basically, we have 3 different services: the console, the server, and the agent. For all of them, we have they are stateful sets, meaning that each replica of the service, each pod has its own persistent volume. Persistent volume case that is matched with the persistent volume, and that can all scale up. With the console, if you scale up the console, you have an active configuration, and automatically there is a load balancer provision that distribute the workload across different instances with session affinity. So the customer automatically are kept on the same pod or the same server. For the master, scaling up means adding new backup masters that are automatically defined, and the load balancer in front will automatically switch all external connection from APIs, dynamic agents to the active master. And here we can leverage both Kubernetes availability restarting the pod on new nodes in case of failures, or also the auto failover that we have now in 9.5 in order to have a simple high availability scenarios for the master. Also, the agents support the scale up, and that's useful especially with pools, because you can define one just with one environment variable. You can specify the pool name for that agent, and in that case, if you scale up, a new pod is created, a new agent is created. The agent is automatically registered on the server, created on the database, on the plan, and it's automatically part of a pool. If you have jobs on that pool, the new agent will immediately start getting new jobs. So very fast and quick scenarios to scale up and scale down agents as well. We also support some scenarios with mainframe, of course. ZWS does not run in containers, but you can leverage Kubernetes to run the DWC or to have agents and pools working with AWS Z using DDM in this case. Just one point about the database. You can use on-premise database. You can use managed database, and we are going to certify more and more managed database on the public clouds. Or you can even use the database running directly in Kubernetes. We still don't have huge experience about scalability of database inside Kubernetes, so for large environment, we still suggest on-premise deployment. So installing on-premise or public cloud, so installing database on VM, so use a managed database. The deployment is done through Operator or Helm charts very easily. You just have to, in case of Operator, as probably will show on OpenShift, you use the Operator lifecycle management. You create a new instance, just specify the parameters. With Helm charts, it's similar, but it's from command line. You fill the values YAML, specify some options, and then the full environment is deployed. All the components are managed and deployed automatically by charts or for the operator. I said we support the scalability. You can scale up them during the deployment or later after they are deployed. In case of operator, the operator creates a custom resource called workload automation, where you fill all the data for the deployment that you want, all the options, and in case of mchart, there is the values YAML that is similar to that one. Here you specify which service you want to enable, how many replicas you want for each service, resource limits and requests, so minimum and maximum resource allocations for each service, connection to the database, and the persistent volumes. So which type of volumes do you need, the size of the volumes that you need. For persistent volumes, you can go with dynamic provisioning. That is probably easier because basically Kubernetes automatically allocates new persistent volumes every time that you need them. But some customers prefer to have and manually create persistent volumes. And so in this case, you can use the selector here to select the specific volumes, and you disable the dynamic provisioning. Also, in case of the agents as said are automatically linked, and by default we also have the option to the default configuration of the server on Kubernetes to have the add workstation also to the plan. So as you start an agent, they're created in the database and also on the plan, and they're immediately available. Also, we automatically configure the engine connection on DWC. So if they are part of the same deployment, you don't need to do that manually. And you can scale the containers. For the updates, it's very easy. You just have to change the version of the container image that you want to use in the deployment. And when you change that, we automatically perform a rolling update. So if you have at least 2 replicas of each service, the update have no downtime. And we automatically update one by one all the images, all the containers. We talk about this. About resiliency, that's automatically managed by Kubernetes restarting the pods, and for any corruption, the switch manager is still available manually or without a failover. Another interesting integration is the one with Cert Manager. Cert Manager is a service that you can add to Kubernetes and that manage the certificates for you. And just enabling that, we automatically use Cert Manager to get new certificates for all our services, and we configure the server, console, agents to use the service. That's very good because it's much better than most customers are doing with keeping the default certificate that we provide, that are basically not secure due to the availability to any customer. And so every new environment using Kubernetes and Cert Manager will get their own certificates. Cert Manager can also use external certificate authorities to get the certificates, and so having also good trusted certificate. You just have to be careful that if you install agents outside Kubernetes, you will have to import the certificate of a work automation server during the installation of the agent in order to allow the agent to connect to the server. Another interesting integration that comes with Entrusted Operators is the one with Prometheus Grafana that are usually used to monitor services and containers in Kubernetes. Just enabling the options, Prometheus in Kubernetes will automatically start monitoring all our pods, and also some additional metrics about liberties, our MSG files, the connection pools, and also the workload in terms of how many jobs are in each state during the day. And we also automatically add a new dashboard in Grafana in order to do that. Here in the presentation, you will find some links to start with your deployments, links to GitHub for the charts and Docker Compose, and the link to the knowledge center to use OpenShift and operators. And also the link to the Automation Hub, where you can get the Kubernetes batch job and install that already on 9.4 and 9.5 that you have.